Hello, today I will be performing the Physics 101 experiment titled The Effects of Object Shape on Motion Down an Inclined Plane. The purpose of this experiment is to understand how the geometry and the mass distribution of two different objects, a solid cylinder and a cube, affect their acceleration and velocity when they are released from the same height. By comparing their motion, we got to see the role of rotational inertia in a very clear way. For this experiment, I will be using the following equipments: inclined plane with fixed angle, frictionless, but it will be a frictionless surface, solid cylinder, cube, stopwatch, roller, and finally projector to verify inclined angle. When an object moves down an inclined plane, the component of gravitational force along the plane is mg sin theta. If the object simply slides without rotating, like the cube, all of its potential energy turned into translational kinetic energy. In that case, the velocity is v equals the square root of 2 times g times h, and the acceleration is a equals g times sin theta. The solid cylinder behaves differently because it's both translates and roots. Its moment of inertia is I equals 1/2 mr squared. Since part of its energy goes into rotation, its acceleration becomes a equals g sin theta divided by 1 plus I over mr squared. When we substitute the value of I for a solid cylinder, this simplifies to a equals 2/3 g sin theta. So theoretically, the cube should accelerate faster and reach the bottom sooner. This experiment allows us to measure that difference and compare it with the predicted values. I will perform the experiment in two parts. First, I will place the solid cylinder at the top of the inclined plane and release it without any initial push. As it moves down, I will record the time it takes to pass through equal distance intervals. This gives me the delta x and delta t values. Next, I will repeat the exact same procedure with the cube, keeping both the inclined angle and the starting height the same. Using the recorded distance and time values, I will calculate the velocity using v equals delta x divided by delta t, and the acceleration using a equals delta v divided by delta t. I will then pilot velocity time and acceleration time graph for both objects and compare the results with the theoretical prediction. Quite minor errors. The results were still close to theoretical predictions. The cube constantly accelerated faster than the cylinder. This confirms the expected effects of rotational inertia